Okay, in this problem we have some men, some women, some children all in a theater together, and we're given some information about them. We're trying to figure out how many men were in the theater. So if I could figure out how many men were in the theater, and then I could also figure out how many women and children were in the theater fairly easily. So we're told that the ratio of men to women is 1 to 3. The ratio of men to children is 3 to 5, and that the total number of people is 561. So when we say that the ratio of men to women is 1 to 3, we mean, and let's just call M for men, W for women, M for men, and C for children. So I have to write these words all over again. That the ratio of men to women is 1 to 3. What we mean is, I'm going to make a table. For every 1 man in the theater, there are 3 women, meaning that if there were 2 men, there would be 6 women. Or if there were 3 men, there would be 9 women. Children, on the other hand, we could do men to children. If there was 3 men, then there are 5 children. So for every 3 men, there are 5 children. For every, see, if there were 6 men, then there would be 10 children. If there were 9 men, there'd be 15 children. For every 3 men, there are 5 children. So let's put together a big guess and check table where we just guess numbers of men, and we'll see what that works out to for total people. And our goal will be 561. So let's take a look. Here's we've got men, women, children, total. Now first, if this kind of makes sense, if I guess 1 man, then I would have 3 women, but there's nothing on this table for children. In fact, if you think about it, if there's 3 men to 5 children, then 1 man to like some fraction of a child, that doesn't really make sense. So we're just going to leave that blank for now. So we're not going to guess numbers like 1 or 2. We're only going to guess multiples of 3. So because that way I can easily say, well, if there's 3 men and there's 5 children, 6 to 10, and so on. So we'll start out with that guess. We'll guess that there are 3 men, which gives us 9 women and 5 children for a total of 14, 15, 16, 17 total. Well, that doesn't work. We'll guess 6 men. See, that would be 12 women, right? Found our table here. Because this is there are 3 times as many women as there are men. And then for children, see, for every 3 men, so it's 2 groups of 3, so it's 2 groups of 5 children. That's 10, 18, 28 total. So we're not getting closer. What if there are 9? Well, there's twice as many, or 3 times as many women as children, so that makes 27 women. And let's see, this is 3 groups of 3 men, so 3 groups of 5 children makes 15. And that would be, see, it's 36, 46, 51, 36, 15, 46, 51. Okay, 51 people total. This is going to take a long time before we get there. Okay? We're going very slowly. So let's see if we can't work this out a little faster. I want to write some sort of an equation where men, I can write this equation right now, men plus women plus children equals total. I mean, that should be fairly obvious, right? The total number of people is men plus women plus children. Well, the problem is figuring out some way to represent the number of women and children both in terms of the number of men, so that I don't have 3 variables here. I could never solve this equation. Well, we can use our kind of our algebra trick for figuring out relationships, to writing relationships as rules. So here, for men to women, notice that on the women's side, it's plus 3, and on the men's side, it's plus 1. So that means that our rule for representing the number of women in terms of the number of men is going to involve a ratio of our rate of change is 3 to 1, 3 to 1. So if I just have M, then W would equal some variation on 3M, right? 3 over 1 to M, 3 to 1, 3 to 1 is our rate of change of women with respect to men. And then we don't have to do any adjustments actually because this works. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So we have our expression there for women. So if I start out with men, then women I can replace with 3M. Now we work on the number of children. Well, here, the number of children is increasing at a rate increasing by 5s, but it's increasing by 5s every time the number of men increases by 3. So our rate of change of the number of children with respect to the number of men is 5 over 3. So that means that for M men, the rule for children will be some variation on 5/3 M. And then we just check it out. Let's see. 5/3 times 3. 5ABC3 times 3 gives us 5. Alright, so if I input a 3 into this rule, it outputs a 5. So it works so far. 5ABC3 times 6 gives us 10. So if I input a 6, output a 10. So the rule seems to work. I don't need to adjust it in any way. Remember, the trick is to look at what are the numbers on the right-hand side changing by. What are the numbers on the left-hand side changing by? So what is our increase in output with respect to our increase in input? And we just write that as a fraction. 5/3 times M. Then we'll test our rule to see if it works. And if it works, like this case, we're done. So this means that down here, children is 5/3 M. And then we have our total. So let's see, M plus, so 1 plus 3, we got to combine like terms. 1 plus 3 plus 5/3, 1 plus 3 plus 5ABC3 gives us 5 2/3, which is 17/3. So 17/3 M equals T. That's our overall rule. So let's just substitute 561 people for T. 17/3 M equals 561. And we just have to divide both sides by 17/3. We'll bring our calculator back in for that. So I've got 561 divided by 17 ABC3 gives us 99. So M equals 99. There's 99 men. Well, let's go back to our table and see how 99 plays out. Let's see. M, W, C. If there are 99 men, and remember the number of women is just 3 times the number of men, so 99 times 3 is 297. And the number of children, okay, so for every 3 men, there are 5 children. So 99 is 33 groups of 3. So there are 33 groups of 5 children. 33 times 5 is 165 children. So altogether, 165 children plus 297 women plus 99 men gives us 561 total. So it works. So our trick here was to think of take our ratios and put them into table form. So we're going to start to fill out a small table that shows how our 2 ratios play out. And then we had to write hold on a second. All right, so then we used our tables that we generated from the ratios to write a rule for calculating the number of women and the number of children from the number of men. So we had to write an equation here. And remember, we looked at what is our rate of change of the number of women with respect to the number of men. So we look at what are our differences over here. What are we increasing by for every increase over here, right? And so 3 to 1, 3 to 1. So that's going to be some variation on the rule 3m. And of course, we didn't have to actually do a variation because the rule worked the first time. Sometimes you have to add or subtract afterwards. On the other side, it was an increase of 5 children for every 3 men, which is really what the ratio 3 to 5 means. So an increase of 5 for every 3. So we represent that as 5/3 m. And then we had to see, do we need to adjust that rule? We tested it out a couple times. It worked. We didn't have to adjust it. So we knew that we could represent the number of children as 5/3 the number of men. And then we just went down here and we wrote an equation that said men plus women plus children equals total. Men plus, instead of women, 3 times the number of men. And instead of children, 5/3 times the number of men equals total. And then we just had to substitute 561 for our total and solve and get 99 men, which we then tested to see if that worked. And we said, well, 99 men, 3 times 99 is 297 because there are 3 times as many women as men. And then 99 is 33 groups of 3. So there must be 33 groups of 5 or 165 children because the ratio is 3 to 5. And add 99, 297, and 165. And in fact, we do get 561. So it worked.